This is the TSMC Fab 18 facility, the world's most advanced semiconductor foundry, producing 3-nanometer chips.
This is the Czochralski process. A seed crystal is pulled from the melt, forming an ultra-pure silicon boule.
Silicon wafer slicing. Large silicon ingot being precision sliced into thin wafers using wire saw. Diamond-embedded wire.
Surface. Silicon surface reacting with oxygen forming ultra-thin silicon dioxide layer. Glass layer only 5 to 10 nanometers thick.
Extreme ultraviolet photomasks being prepared for lithography. The pattern contains billions of features. Inspection systems
uses extreme ultraviolet light with 13.5 nanometer wavelength, enabling 3 nanometer resolution. Light source.
Exposed wafer undergoing post-exposure bake on precision hot plates.
Ion implantation, the doping process, involves wafers entering an ion implanter to dope semiconductor regions. In a CVD reactor, precursor gases flow into the chamber, causing chemical reactions on the wafer surface.
Chemical ventilation conversion, or CMP. Wafers undergoing the CMP process for global plastic.
The automated probe station measures responses on each die. Failing units are marked with an ink dot.
Package testing and burn-in. Packaged A19 chips undergoing final test and reliability screening. Chips in testing.
The deep ultraviolet tool had an unscheduled stop at 0400, but we're back on track.
Understood. I'll keep an eye on the EUV throughput.
With an investment exceeding $10 billion, this facility produces tens of millions of OLED panels annually.
Organic tool deposition, evaporation. OLED organic layers being deposited in ultra-high vacuum chambers.
Polarizer film application. Individual cut OLED displays receiving polarizer films on both sides. Polarizer is
The driver IC is precisely positioned on the ACF. Thermocompression bonding then activates the conductive particle.
Flexible printed circuit attachment. A flexible printed circuit board, or FPCB, is being attached to the display for external connections.
OLED display module being laminated to ceramic shear, quick place of.
Through the fusion draw process, molten glass forms a pristine sheet. It then undergoes a dual-ion
Ceramic shield glass sheets undergoing precision processing. CNC machining cuts the glass to exact dimensions, achieving clean edges and precise cutouts.
Port. The always-on display shows time and notifications even when locked. Thanks to OLED technology, most of the screen.
The iPhone 17 Pro display supports high dynamic range content, reaching 2000 nits peak.
Qualified display modules are placed in custom-molded plastic trays, protecting the fragile glass. The trays are stacked in ESD protective boxes.
This massive Sony complex in Kumamoto manufactures image sensors for smartphones, cameras, and automotive. Image sensor technology introduction. Image sensor converts light into electrical signals, creating digital images.
Automated probe stations perform electrical and optical testing on image sensor wafers. Calibrated light sources measure pixel response and
Wire bonding. Ultra-fine gold or copper wires connecting sensor die pads to substrate pads. A typical Sensor shift optical image stabilization mechanism. Unlike traditional OIS moving lens elements, sensor shift moves the entire image sensor, compensating for camera shake.
Complete camera module being assembled, integrating all components. Module housing, usually metal, with precision mounting surfaces.
Modules undergo comprehensive testing and calibration. Automated image analysis checks resolution and color accuracy.
Manufactured using the Czochralski process from molten aluminum oxide at 2040 degrees Celsius. The
Camera quality control and Apple standards. Final camera quality control before shipment to iPhone assembly. Each camera module tested against Apple's
Economic overview of the iPhone 17 Pro camera system. Component costs. Main 48 megapixel sensor with OIS $60. Ultra wide
Titanium raw material, aerospace-grade. Titanium ingots and billets used for iPhone 17 Pro chassis manufacturing. Grade 5 titanium alloy.
Brushing process. Precision rotary brushing using special abrasive nylon bristles. Brushing direct.
Sandblasting process. Compressed air propelling fine abrasive particles at the titanium surface. Impacts creating uniform fine texture. Media size controlling finish coarseness.
The total titanium frame cost is approximately $60 to $70 per iPhone Pro, compared to just $18 for aluminum.
We offer several color options, including natural, light, black, blue, and gold titanium.
Precision-engineered antenna lines embedded in the titanium frame, connected by flex cables to the baseband modem and Wi-Fi chip.
Installing the remaining 2 cameras, completing the Pro camera system. We use adhesive seals and connect the flex cables to the main board.
The True Depth camera system includes the infrared camera and dot projector. Face ID calibration is critical.
Precision titanium acoustic chambers provide high output and low distortion. The microphone array enables clear voice capture and spatial audio.
Installing Taptic Engine, providing iPhone's haptic feedback. Taptic Engine's linear actuator using
The serial number is verified and registered in Apple's systems, linking the IMEI and confirming AppleCare eligibility.
Accessory preparation. The cable is folded and tied precisely, the documentation folded to exact size, and all items organized in a specific layout for packaging.
Quality documentation and certificates. Final documentation package accompanying iPhone shipments. Documents including batch per quality certificate,
Our daily production output is consistently over the target, with a 97% first-pass yield across all 50 lines.
The yield rate is holding steady at 99.8% across all shifts.
And the cosmetic defect rate is still in the single digits for ppm.
Display optical analysis, advanced testing. Specialized display testing beyond the production line.
The video playback test is holding steady at 22 hours, 55 minutes.
That confirms the 23-hour claim under standard conditions.
Achieving global market access requires extensive regulatory compliance. We secure certifications like FCC and CE. Retail packaging for different markets. Preparing iPhone packages for regional differences, including SIM configuration, physical SIM, or eSIM only for the US.
This model has the new customizable action button right here, which gives you quick access to the camera or flashlight.
The iOS diagnostic data shows a spike in performance issues.
Look at the Genius Bar visits. It confirms the trend. We need to analyze the failure modes.
Retail sales analytics and demand planning. We monitor real-time sales data across all channels.
Apple provides major iOS updates typically 5 to 6 years after launch. Through trade-in, our Daisy robot recovers insurance. The environmental impact of iPhone production starts with its supply chain carbon footprint. Sources of emissions include material.
As an Apple authorized service provider, we ensure all repairs use genuine Apple parts, extending the life of your device.
The iPhone 17 Pro leads the premium tier at $1,199. With seamless ecosystem integration,
the broader economic significance of iPhone production involves hundreds of thousands in the supply chain. Highly paid female engineers.
With continuous evolution ensuring future generations are faster, have better cameras, longer battery life, and are from raw materials to your hands in months. The iPhone 17 Pro, the pinnacle of human manufacturing capability and global commerce.